Hello everybody! In this video I'm going to talk about two exercises in chapter 6.5. Chapter 6 is all about functions, and subsection 6.5 is covering what's called the accumulator pattern, which is a method that we can use to compute values that we need to compute, and we'll use the accumulator pattern frequently in this class, and I've definitely noticed in previous classes that it tripped some people up, and so that's why I wanted to make this video, to make sure that this topic is clear and just show you how I work through problems where I need to use the accumulator pattern, or I choose to use it. So a lot of times there's more than one way to solve a problem. So the first activity that I wanted to work through is activity 2. And in this activity, we can see that there is a function that's going to compute the square of a number. We've seen this before in previous videos. But this function, instead of maybe just using something we'd seen before, like x times x, that could be this. That's one way that we can use Python to compute the square of x, right? In this version of square, the accumulator pattern is used. And so we have some running total value that we initialize to 0. And what we're going to do is some number of times that's determined by the input, we're going to do some operation on that accumulator variable, our running total. And what do? We set running total equal to, we reassign that variable running total to be whatever it was before plus our x value. And how many times do we do it? We do it x times. And after that's all done, we return it. And in order to see what happens, there's some additional code down here. And so let's just go ahead and run this and see what it does. So we see that we print the result of, so to square was 10. So the result of 10 squared is, what is square result? Square result is the variable that gets the whatever square of 2 square was. And so we see the result of 10 squared is 100. So that's good. And let's just go ahead and move this over to idle, just to demo that again, since that's where you're going to be writing your programs. Oh, I still have an old idle from our last video. So let's go ahead and reopen idle, fresh idle here, and let's make a file. And I'm going to save this in my CSCI 127 folder, and I'm going to call it square.py. Just call it square.py. That seems fine. And now let's just make sure that it runs. All right, so we get the same result in idle as we did in the book, so that's good. And so one thing I wanted to show is what happens when we follow this note here. It says, what would happen if we put the assignment running total equals 0 inside the for statement? So let's go ahead and do that. So we'll go back to idle, go to our file, and so that's saying what happens if this running total accumulator variable is set to 0 inside the for loop, because that's something we might have done. And so let's just go ahead and run this and see what happens. So I'm running it, and I get the result of 10 squared is 10. So maybe I already have a guess about why this is happening. But one thing that I can do to just investigate what's going on is just add some print statements in here. See what's happening. So maybe I say, every time I go through this, I'm going to say the value of running total is, and I'm just going to print out whatever running total is. And so if I have a hypothesis about what's going on, I can test it this way. If I just don't know what's going on, this is a good way for me to get some ideas. So let me run this. And what do I see? Well, just like I might expect, I'm executing the statements inside this for loop 10 times, but this time, every time the value of running total is 10. It's not increasing like I would hope that it might. And if we take a closer look at what the code says, we can understand why that's happening. So every time we go through an iteration of this for loop, what are we doing? We're setting running total back to 0. So maybe just, I'm just going to print out what the counter is. Counter is counter. If maybe I was still confused, I'm trying to understand what my program's doing. Sometimes it's useful to print out your counter. And yeah, so every time we're setting the running total back to 0, and then we are adding what is x. X in our case is 10, but maybe we can print it out as well if we weren't sure. X is, let's go ahead and run that. So we see every time we go through that loop, x is just 10, and so running total gets set to 0, running total gets set to 0 to 10 plus, or yeah, 0 plus 10, and then we start over again. So that's what happens if we do what that note says. So next, I wanted to take a look at activity 7. So this is another activity with some more tasks for us to do. So let's just go ahead and paste what they have in the book into our file, and we can take a look at it. We still have this square function, and in fact I think it's the same as it was before. And let's just see. Oh, we need to save it. Oh, I think. Oh yeah, it's still just in our square.py file. So let's look at what we're supposed to do in this activity. All right, so we're supposed to first, let's try changing the value of 2 square in line 9 to -10. All right. So we don't have line numbers in our idle file viewer here, but I think this is the line we were supposed to look at. So here we've changed 2 squared to -9, and in your head, let's try to think about what do we expect to happen. So when our x value is -9, is something weird going to go on? And what is it? So I'll let you just think about that for a second. And then I'm going to run this, and we'll see if your guess was right. And we see, okay, something weird's definitely going on. We're not getting what we want. So let's try to understand what the Python code is doing and why it's not giving us what we might have hoped or what we want. So the value is 0. And maybe we don't know, maybe we have a guess, but let's say we really didn't have any leads on this. So what would be a good thing for us to do? Just like we saw before, we can print out information as our program executes to try to understand what's going on. So one thing I might do is say print what is the counter, print what is running total, and then I can see just some more information about what my program's doing. And wow, what happened here? I don't see anything, right? And why is that? So what does that mean that I don't see any extra information? That means that we never enter this for loop. And so this is a good opportunity for us to come over and use the shell mode of Python to just test out some ideas. So one idea we might have is this range function. What happens when we pass in -9? What happens when range gets a negative number? So we know that if we do something like for counter in range 5, maybe we print counter. Oh, yeah. So now counter is going to take the values 0, 1, 2, 3, and 4. And we see that happening. But what happens if we do for counter in range -5? We can print out the counter. Nothing. And that's because range is giving back everything from 0 to -5 as long as that thing is less than -5. Well, 0 is not less than -5, so we never get, that range function doesn't return anything to us at all. So that is what's going on there. So let's see what the book says. We now see that our function has a semantic error. That means that it runs, but the logic is not matching up with what we want to do. So now, it instructs us to change the value of 2 square back to 10 and run it. That seems like a reasonable thing to do. Let's just go ahead and do that. And maybe we could even return, we could comment out, say, assuming we're going to need these later, but we can comment out those print statements and just see the overall result of our program. Okay, now it says, what would happen if we change running total equals running total plus x to use multiplication instead of addition? So let's go ahead and do that. In our file here, so instead of, the goal here is to use multiplication instead of addition. So what happens if we just multiply instead of add every time, right? Let's try this out. And I would take a couple seconds here to think about what you expect to happen. So every time we go through the for loop, we're updating our accumulator variable to be whatever it was before multiplied by the number that we put in. So in this case, it's 10. So take a second to think about what number you expect to see, or maybe is it a big number? Is it going to be the correct value, which would be 100? Now let's try running it. Well, we got 0. So let's try to think through, why did we get 0? Well, if we don't have any ideas, it's always good to print. So let's go ahead and save that and run it. So now we're going to see the value of the counter, and we'll see the value of the running total. So from this output, we can confirm that every time we go through the loop, we're still at 0. We're not building up our number and then maybe setting it to 0 at the end. We're just always keeping it at 0. And let's take a look at why that's happening. So the first time we go through this loop, running total is 0, counter is 0, and then we update running total to what? Let's say our input is 10, so x is 10, and we multiply our current running total by 10, and what do we get? We get 0, right? And so then running total is 0. The next time through, counter is going to be 1. We could even maybe look at the output. So counter is 1, running total is still 0, and we multiply 0 by 10, and what do we get? We get 0 again. And that's what happens every time we go through the loop. Now let's see what the book wants us to do next. Okay. It says, it is very important to properly initialize the accumulator variable. It asks us to do a web search on additive identity and multiplicative identity. If we do that, we would see that the additive identity is 0. That's the thing that doesn't change our value when we add stuff to it, right? So 5 plus 0 is 5. Any number, if we add 0 to it, it's 0. The multiplicative identity is the number that that same property holds for multiplication. So if I have any number, say it's 5, what is the number that I can multiply it by to keep 5 at 5? And that is 1, right? So 1 is the multiplicative identity. So now the book is saying we should properly initialize the accumulator variable to the multiplicative identity and run the program. Sounds like a great idea. Let's try it out. So this is where we initialize our accumulator variable, and let's try initializing it to 1. And let's run this, and we can keep our print statements in and just see what happens. Alright, so the first time through, we multiply 1, running total was 1, by 10. The second time through, we multiplied again by 10, so what's 10 times 10? It's 100. And then again, we multiply by 10. And so in the end, what we get is 10 times 10 times 10 times 10, 10 to the 10th is that number. So we're getting closer, but we're not quite there to using multiplication as the accumulator mechanism here. So let's see what the book says to do next. Okay, now we get an answer other than 0. However, the answer is not the square of x. It says, how many times do we need to execute line 5 to get the square of x? So line 5 is this running total command. So if we look at our code here, how many times do we need to execute this command? And, well, we can look back what happened when we ran our program. The first time we got 10, the second time we got 100. And so it seems like what we would like to do is, instead of doing this x times, we would like to only do it 2 times, right? And let's just go ahead and see if that works. And it does. And so if we think about that, why does setting this to 2 work? Well, when we raise our x to the second power, we that's like multiplying it 2 times, right? X multiplied by x, right? And what are we doing here? The first time through, we multiply 1. Another way we could think about this is, what are we doing? We're multiplying 1 times x again when we do this 2 times. Back, this is sort of our multiplication solution, right? What was our addition solution? What did we do? We started with 0, then we added 10, we added 10, we added 10. Oh, let's actually do this in general. We add x, we add x, we add x times, right? And that's our addition solution. And that's why that works. All right. So we just did this. We changed line 4 to repeat the correct number of times. And now the book wants us to see if the negative input works. Let's try that out. Okay, so let's do negative 10 instead and run this. And we get, what is the square of negative 10? It's 100, and that's what we get. Let's see. Aha. So the book is talking about, now wants us to just check out if our function works also for 0. Because for squaring, you have one behavior for positive numbers. Positive numbers should give positive squares. Negative numbers should still give positive squares. And then what should 0 do? The square of 0 should be 0. And let's see if that works. Oops. We'll run it with 0. And the result of 0 squared is 0. So the last thing I'm going to do here is just clean up my print statements and maybe delete this comment. But I do think it's really useful to think about, what is my program doing? But I'm just going to delete these comments because we don't need them anymore. And I'll just save it and make sure that I didn't introduce any errors accidentally there. And it looks like that's still running. So that was activity 7 from 6.5 on functions, covering the accumulator pattern. Thanks, everybody.